So I'm Kevin. I'm a developer at Yeti, and today we're going to be talking about the importance of readability, and readability more particularly in the domain of programming. So before we start, first thing to think about when it comes to programming is that they're actual languages. Languages in the same way that I'm communicating to you guys right now, and the paradigm for programming languages kind of started 100 years ago when we started creating machines that we'd be able to communicate to. And we had to communicate to them in a very different way than we communicated to ourselves because it was a lot more low level, similar to assembly languages, or if you guys have heard of other low level languages, you're kind of manipulating more hardware focused elements of the machine than actual, than kind of higher level things that other people have created. So when it comes to language, especially programming languages, as I was saying, they used to be really hard to understand. They're more machine-centric. Over time, though, certain people had efforts in the 50s, especially with the language Fortran, which was created to make an effort to make things more kind of readable for the actual programmers themselves, so they can kind of communicate with the machine in a more efficient manner. And what that meant was the ability to also communicate with other developers in a more efficient manner as well. Similar to if we all know English in here, so we're able to communicate with each other. But the way it used to be was you'd have to have really specific knowledge of a particular programming language or a particular system in order to actually be effective in it. So as I'll get to later, that causes a lot of issues when it actually comes to developing software, because there's a lot of knowledge you need to gain before you're effective. And one of the other paramount's that's going to be a recurring theme throughout this whole thing is that writing code is really not that bad compared to reading code. At least that's what I personally believe, and that's what I've heard from a lot of people as well. It's kind of, there's writing things and writing new things, and you can kind of create solutions to problems that really make sense to your head, but they might not necessarily make sense to other people. So kind of establishing that shared language between developers is paramount to effective programming. And one of the most important things that we have to do basically every single day, multiple times a day when we're programming, is actually naming things. When there are a few different types of things that we normally name, some of those are called variables, which kind of store data. So for example, I have my name Kevin, and that's storing that I am that it uniquely refers to myself. And other things like methods or functions, which are kind of the building blocks of most programming, which allow you to actually communicate with those functions to each other. And the importance of those functions with each other is that if those aren't really clear or well known to the developer, then we need to take a lot of time to actually try to understand what those mean. And that usually means diving deep into the source code or just really wasting a lot of time and wasting a lot of cycles kind of understanding the stuff. So a good example for a primer for why variable naming is important is if we just have the word name, which we normally get in most of our applications. We have users, we normally fetch data for them. If we were to just say name, we already operate under certain assumptions. And for every one of us, we could be operating under different assumptions right now. One of those could be that the name itself is referring to just the first name or the full name or some combination of those. And when there's ambiguity like this in the code, then it sets us up for creating bugs in the code. It also makes it so we have to do, as I was saying before, some deeper diving to actually what's going on. So a better name for something like that would be first name. So we actually know exactly what it's referring to. And this, another example, which is different data type, is called a Boolean. Booleans are either kind of true or false, yes or no. That's kind of how we define them, so it's kind of easy to understand. And standing, for example, is something I'm doing now, and you guys are sitting. So let's say on our user, we have a standing variable. If you just look at that without context, it's kind of hard to understand exactly what it's referring to, especially if you're in a larger ecosystem and there might be words kind of related to that. So a better way to kind of name this would be something like is standing, which kind of makes it a lot more declarative and makes it more basically just more like English in terms of how we actually think about things and process information and communicate with one another. And what that does is basically allows us to ramp up a lot quicker on some of the code. These are obviously very simple examples, but as we'll get to later, it applies to more complex ones as well. So what I was just talking about is kind of declarations. So declarations, as we know, they just say things very obviously. And that is something that we always try to aim for in our code, where we're saying like, I'm gonna fetch this user and bring it back to our state and then display it for the front end. So when our users are using an app, they actually could see their face and they know what their name is and if they made a typo or anything. And this kind of philosophy was spawned back in the day when people kind of realized that, hey, this machine code really isn't cutting it. I created this whole thing, but now now somebody else is coming onto the project. And I have a bunch of variable names and a bunch of paradigms that I've set up that don't really communicate exactly what's going on. And even though the business logic itself might be complex, the code itself makes it even more complex than it has to be. So for example, this is a function name that we have, and it's called create user and fetch projects. And why this is a good function name is because we know exactly what it's doing. Some critiques of this might be that it is very long, and usually you only have like 60 lines in your editor before you really kind of start losing the space on your screen. So people usually opt to create shorter names than this, so it kind of appears on your screen. The problem though is if I were just to create this, call this function create user, and not create user and fetch projects, then all of a sudden we're introducing ambiguity to the system again. And even though it might be fetching the projects as well, and that's just kind of a side effect of what we're doing after we kind of create our user and like go to their profile and get their projects, then we don't really know exactly what's going on. And that's hidden from the other developers that are going to come to this, and they're going to make assumptions about how this code works. And then those assumptions are obviously going to be erroneous, which causes problems. And again, this is another thing that I found where when we make assumptions about some of these names and what exactly their functionality is, then we wind up putting other new things in incorrect places, which just makes the whole kind of code ecosystem itself a lot more complex, a lot harder to understand, which again kind of relates back to when you have other people that kind of ramp up to the project, it's a lot harder to understand exactly what's going on. So when we think about naming our variables, it adds intent to the code and it makes it a lot cleaner. And what this does is when we're actually thinking about coding and we take the extra time to really think about, how should I name this thing? It really forces us to kind of separate in our own head and really understand, how many different things do I need to separate this into and kind of what do they connect to? And I'll touch upon this later, but obviously there's a lot of other things that we need to think about on a day-to-day basis that really impact this. And since we're always under a time crunch, we're like, hey, we don't have time to do this. But when we don't actually think about these things, then the code bases that we create kind of lack that same focus and vision, and it makes it a lot harder for other people to understand. A common retort to some of the readability stuff is performance. And performance, I'm going to talk about, since my experience is mostly in web applications, is performance of the kind of the JavaScript that we're running or different algorithms that we're running. So usually a lot of things we have to think about is, hey, is like the page load speed, is it fast? Because we know if it's like 500 milliseconds more, then users are actually just going to leave the website, which is like something that Google has figured out. So we really need to care about that as well. So it's like add that to the bucket list. But the problem when we actually think about that performance is that we don't really think about the underlying mechanisms which our code actually kind of compiles into. So JavaScript itself, before it actually hits our web browser, goes through what's called the V8 engine, and that kind of compiles our code. So it changes it from more of the high-level language, which is more English-like from what we're doing, to the more low-level machine-like language. And a good example of this is one of the things that I've personally looked at in the past, and I know I've got questions about, is like, what type of loop should I be using in my code? And if you're to go to mozilla.org and you're going to look at all the different performance changes, you're like, oh, this one's like 10% more efficient. I should really be using this one over this. But in this case, I shouldn't. But in reality, it doesn't matter at all, because the V8 engine itself really just handles all of those optimizations for us. And when we think about doing some of the more performance-centric things in our code, instead of just focusing on what's going to be better for the person after you to understand, then it's actually not saving as much time as we think. And this is a specific example of what a compiler does to our code. So as you can see on the left, we have two kind of statements. One of those is that we're multiplying b times c plus g, and the other one is we're multiplying b times c times e. And as you can tell, there's some shared code between the two, and that's b times c. So what we would have the inclination to do normally is be like, oh, the code's actually going to be calculated twice. We're going to run b times c twice. So that's inefficient. We have to solve that. But in reality, we could do that ourselves, which is fine. But the compiled version, which is what I was talking about, V8, actually automatically does that for us. It has a lot of heuristics like this that's really intelligent, that just kind of makes all these optimizations for us. And some final notes on the performance aspect of that stuff. The V8 engine and JavaScript is really, really fast. So it does millions of calculations per second. So whenever we're doing things like this, it's really adding like probably one millionth of a percent in terms of how much more effective the code is running. So in that sense, what I've heard mentioned before and what I would agree with is don't optimize until you kind of run into issues with your code. Something else readability-wise, which is important, is types. And what types do is they actually declare exactly what data you're looking at. So before, when I was mentioning strings and booleans, it makes it very clear when you're looking at the code the first time exactly what type you're looking at. And that's important because you don't have to actually dig too far into the code itself to have a solid understanding of what's going on. So these are kind of examples that we use. These are all pulled, these are pretty generic, but these are specifically pulled from TypeScript, which is the language that we use a lot on the front end. And what this does, it provides you a lot more context with exactly how the application is working, which allows you to form a mental model about how things work a lot faster than normally. And what it also does is it establishes contracts between the methods and modules that we're creating. And the reason that's important is similar to what I was talking about before, where when you add types to a system, it really kind of makes you think about exactly how you're programming it. And the retort to this sometimes is that it slows you down, which is true, obviously. Since you're adding more lines of code, you're taking more time to think about these things. Like I've personally gone down rabbit holes where I've thought about naming things for like 5 minutes before, which by all intents and purposes is usually very frowned upon within the industry, where people think you're wasting your time, you're not actually helping the ecosystem at all. But I think, in my opinion at least, that's actually a lot more medium-term and long-term oriented, which makes it so, I'll touch upon this later in terms of documentation, but it makes it so your code's a lot more self-documenting. When your code's self-documenting, that kind of makes it more of like a living and breathing organism that you could kind of understand. So this is a specific example of very explicit and type-heavy code. So what it kind of allows us to do is allows you to get like a very quick glimpse of exactly what the code is doing. I actually modified this today because it actually wasn't as readable. It just said get tags that fit. So instead, it just makes it a lot more explicit in terms of its nature. And it's not that helpful for you when you're writing it because you already understand what it does, but it's always helpful for the person after you. And sometimes the person after you is yourself looking at the code a year later when there's bugs in it. So how does all this actually relate to our understanding? So this, the tickler, is, as you guys know, it's tickling, right? There's like one definition we all have for that. But this is actually a method that we came across yesterday in code. And even though it's like a bit funny to look at, and Rudy and I had a good time trying to figure out what it did, it's really bad because, as I was saying, it has a single denotation, and that denotation really has absolutely nothing to do with development itself. There's no ecosystem that really exists that kind of helps us understand exactly what this does. And because of that, we had to go actually look at the code itself, spend an extra 5-10 minutes to understand. So as you could tell, that extra 5 minutes that somebody before us didn't really take to kind of really create a good name for this caused the developers afterward another 5-10 minutes. And as you could tell, one person creates the code, and normally the lifespan of a code is many years. So you have more and more people look at it, and every single time they do, they lose that same amount of time. So I could probably guarantee you that this Tickler code, which is in, won't shame anybody, but it's in a really large code base from a large organization that a lot of other developers have touched. And I am very positive that every other person has ran into the same situation. So it's definitely costed hours and hours of developer time, which is silly because it's such a silly name, but it's actually true about kind of what happens when we don't name things correctly. So these are lines and circles, but they correspond to basically a graph. And we can kind of represent these abstractly about multiple touch points within our application. So it's obviously when you just look at it by itself, we're not going to think about anything. But when we write code and when we try to kind of create modular ecosystems on the front end, we have to kind of create structures for those and adhere to those structures. And when we do that, then we actually kind of have a unified vision within how every single developer kind of approaches a specific problem. So a good example of this, if you guys want to do some research, is what are called observables. And that is basically a very opinionated coding paradigm that multiple people follow. And when you do that, that knowledge is basically transferable, which means that many people share this similar mental model, and when they come across problems that are similar to this, they understand it. So the question is, in our Tickler example, for example, how much do we actually have to understand these touch points in the application? When, from no study whatsoever, from my own personal anecdotal experience, whenever we have problems we need to solve, we're usually touching at least 6 to 7 parts of the application, which are usually either files or methods or functions. And all of those kind of has their own unique sets of things that they're related to. So how deep down the rabbit hole do you normally have to go before you actually solve the problem? And ideally, you go as shallow as you need to before you actually understand what's going on. And the easiest way to do that is to make the variable names that you have in your application actually really explicit and really correspond to exactly what is going on. So in our example here, the Tickler is its own kind of touch point in this application. And when we actually have to try to understand it, we might have to go to its nodes to really understand what's going on. And that could have been solved a lot easier by just changing the name. So along the same lines, the more information you have to retain at a single point in time, the more of a burden it is. I'm sure you guys have heard of the word flow, especially in relation to programming, where somebody codes for like an hour straight, they get in the flow of things, somebody taps them on the shoulder, you get a question, all of a sudden you're gone, right? And that's because you're thinking about complex things like these, and if they're not very obvious and not hard, and there's a lot of them and it's hard to retain, then you're going to lose it really easily. And that's a serious problem because that's a serious problem for efficiency. So how do we account for this burden? One of the ways to do that is to create documentation. And creating documentation comes in a few different forms. One of those is like, basically you could have a handbook, say this is how the product works, this is our coding philosophy. Another way you could do this is on the individual methods and functions. You could just kind of create documentation above it that says this method takes in a name and it takes in a color and it does this thing. But the problem with documentation is that it goes stale. And when documentation goes stale, it's bad because then we have then we kind of have a mismatch between what the code's actually doing and what the documentation says it's doing. And the solution to that obviously is, okay, well, update the documentation more often, but often we don't really have too much time for that. So as I was mentioning before, if we focus more on the readability of our code, then it'll be more self-documenting, which kind of solves this problem. The last thing, which obviously plays into all this, is that as developers, we're constantly under a time crunch. We have a lot of deliverables we need to meet. We have a lot of considerations we need to do. And these are obviously some of them where we deal with a lot of responsive web design. There's testing, there's accessibility we need to think about. We need to think about performance and managing state and managing our edge cases, and is our application secure? So as you can tell, readability is just a single point on the numerous things we need to think about. But what readability kind of allows us to do is prevent the necessity of tribal knowledge. And tribal knowledge is when, in general, it's when something's just passed down generation to generation. And in our case, when it's just passed down from developer to developer, we have to kind of ramp up and create a working knowledge of the ecosystem. So that's why typically when we talk about velocity, our velocity is lower for a while. When people are at companies for like 4 years, that's sometimes how long it takes to really get an understanding of how things work. And even though sometimes that might just be a symptom of the size and there's not much you could do about it, there are methods to kind of really account for the complexity of systems and be really thoughtful about how we set those up and how we kind of name them. And it kind of relates back to, sometimes it's totally okay to go slower because it'll actually make you go faster. And when you create more intentful code and you kind of prioritize readability and not just the short term, then the kind of paradigms you create and the code that you create will be a lot easier for people after you to understand. And which kind of relates to the paradigm which I really live by, which is code for the person after you and not yourself.